Okay, welcome everyone to our event today. Unlock the future of asset inspection, stay one step ahead. My name is Lisa Stanis, and I am the Director of Customer Development here at Sharper Shape. And I am joined with my colleague, James Conlin, who is our Product Manager. We're so excited for you to join us today. We have a new feature that we are launching from our digital twin software called Asset Insights, and James is going to walk you through and show you a look of what it is, what it can do. But before we get started, I just have one housekeeping tip. There is a chat box in the lower right-hand corner. So at any time during the presentation, if you have a question, please feel free to type in that box. We're going to hold questions until the end, and at the end, we'll go through those. So without further ado, I will hand it over to James.
All right, thank you very much, Lisa, and thank you everyone for your time. As Lisa mentioned, my name is James Conlon. I'm a product manager here at Sharper Shape. And for the past 5 years almost now, I've been working with our team of real expert developers, designers, and testers and customers to develop this living digital twin platform we call Core. So I'm going to share a screen now. And what we're going to walk through are the new bits of functionality and the really cutting edge stuff that we're bringing to the table in terms of machine learning, computer vision. So Asset Insights are a combination of additions to our image processing pipeline, capabilities in our data model, and for the end user, AI-powered tools to help speed up inspection, as well as for organizations to invest in the future of the safety of their network. So in the next section, we're going to walk through a little bit of the history of Sharper Shape, the actual solution space we work in, and exactly how Asset Insights adds this series of capabilities so users and customers can get more out of their remote sensing projects to better safeguard their network. All right, so here we can actually just get a little preview. You know, whenever you see any ML or CV models, you always want to see those bounding boxes. We have, like I mentioned, 3 sort of pillars here: image processing, tools for end users, and updates to the data model. And that Sharper solution sphere. So here in Sharper Solution Land, we operate as a software vendor for some of the US and the world's largest IOUs, so investor-owned utilities and smaller utilities, as well as their vendors. So if you are a drone service provider, you capture images, you're looking for a sort of end-to-end solution, you can lean on us to help you organize your operations, actually operationalize this data at a huge scale. We've got a really large offering. We've got a very wide and deep platform. So it's nice to sum them up and think about them like this, I think. For workflows, these are tools that help utility workers and your vendors get jobs done. Key technologies are our utilization of cloud computers and our whole architecture that allows us to deploy complex data analysis pipelines at scale. And solutions for housing and structuring and accessing data. Realistically, almost all Sharper Shape solutions live in this section, a warehouse that stores, structures, and serves the data, as well as the actual interfaces that users deal with when they're accessing our platform. But I do want to highlight it here because it's going to become useful. We are built currently on AWS, so it's not a huge task to roll it out somewhere else. We do have integrations with GCP and Azure coming soon, but so right now we are AWS. But in the workflow space, we support manned and unmanned aviation capture projects. We support on the ground line crews and provide them the tools to get their work done, track any of their findings on network infrastructure, even fully control their scope remotely offline. We also support desktop review for utilities or vendors that are capturing enormous volumes of data. Right? They've been using Sharper Shape's desktop tools to lower the cost of site visits and maximize a qualified electrical worker's time. So maybe an inspector that sits somewhere in one state and the actual images roll in from another state, they log on to Core, our solution, and they just look through images like it's a library, or maybe a utility has a vendor that does this for them. There's no more driving from site to site, so inspectors can save a ton of time. It's the difference between them visiting 30 or 60 distribution structures per day. Together, these tools help our customers measure the health of their network, thanks to both visibility and accountability. We see find rates in these projects sometimes greater than 45%. So if you inspect 2 poles, you're going to find a problem with one of them. A drone team captures an image, and an inspector looks at this image cold, has never been on site, can create a notification or some kind of report about the some condition on the pole, that, a flashed insulator, what have you, from the drone image without visiting the structure. It's all tied geospatially back to the asset itself. So we take a snapshot of a GIS database, we analyze the spatial properties of an image, and create an actual object that relates to their finding, and ship it out like a PDF, a dashboard, integrations. We'll get more under the hood soon, but next we'll take a look at some of the key technologies. So SharperShape was actually founded. We'll go one more and look at the key technologies. Yeah, SharperShape was actually founded out of the Geospatial Research Institute in Finland about 10 years ago. We came up with a proprietary algorithm for tree segmentation in LiDAR point clouds. So every green organic cell looking structure here is a tree. We've been used to deploying these models at enormous scales now for nearly 10 years. Next, we came up with, and veg analysis, of course, goes hand in hand. Next, we came up with a solution in the auto-vectorization space. So for really fine-grained distribution assets, vector models that actually describe the as-flown shape. So you can see catenary wires, lines, service drops, even things like transformer attachment points automatically classified and vectorized. Lastly, and this is where we get to show something really fun, we brought the Eclair machine learning classifier to not only our customers, but we released an open source dataset so anyone can use it to train their own sparse tensor Minkowski engine ML classifier for point clouds. And if you want to see how this looks at scale, this is something that's just always quite eye-opening for people if they've never seen this. So when your vendor or you guys capture a point cloud, you have just a bunch of points. Each one of these is an XYZ, right? A laser reflected off, in this case, a leaf, or over here, a power line, or over here, a house or a building. And what the Eclair ML classifier does is it separates all of these points into, I think, 31 distinct classes. When the points roll in, they're all homogeneous like this. There's some variation, but in general, they all can be visualized the same. When classified, you can actually see the Eclair point cloud classifier can tell the difference between primary and communication wire, can tell the difference between road and ground. Every vehicle is classified here. And this enables us actually to roll out really high quality auto vectorizers. So we can actually at scale, an unbelievable scale and level of detail, vectorize distribution network. Go back one slide and take a look at the solutions for housing and structuring the data. So when you sign up with SharperShape, you get a core company. So this is your unique ID inside of the core ecosystem. All of your data is separated from every other company. And within your company, you have different projects. Your projects might be collection events. They might be business units. You access them by going to WebCore. Some of your workers will go there. Some folks will use the iOS app that we build in-house. And advanced users soon will hopefully take part in using our API, which is a really robust and geospatially enabled API. So you throw in some geometry, you throw in the name of a circuit, and it will respond with all of the point clouds or the latest image that captures that location or that circuit. It's really flexible and it's really exciting. It's a joy to work with. All right, so this has been the lay of the land in SharperShape world for a little while. With Asset Insights, we're adding functionality to all three of these pillars. And we're looking to support our users and customers who are trying to deploy state-of-the-art computer vision algorithms trained for the sole purpose of fulfilling our vision for how ML deployment at scale should behave. Here's what we're adding, and this is what we're going to talk about for the rest of the day. In workflows, we're adding powerful ML-empowered inspection tools and a whole suite of review tools that we'll demo live here. The backbone of Asset Insights revolves around our inference pipeline architecture, where in near real time, and I say near real time because it really takes about 20 seconds, every image or all images are run in parallel through your project's inference pipeline. Every project gets its own pipeline. You configure it, you customize it. Results come in two flavors that we'll get into. And then this is all supported by our detection, which we're calling these objects detections. So an ML model with this name detected an insulator. And then another ML model classified this insulator as flashed or rusted or chipped or something like that. Here's once again the whole platform. Asset Insights results come in two distinct flavors. And we'll actually go and talk about these now and what it means to use Core with these insights. When you upload an image to Core, the ML pipeline attempts to detect instances of each component in the image. With one single image, regardless of whether it's from the ground or the air, our state-of-the-art model detects the utility pole and up to 26 different components. So with this image, all of a sudden, you get a pretty decent pole inventory. You got the 3 cutouts, you know how many insulators you are. You can even see some of these connectors up here. Pair this with 3D modeling, and your pole loading or engineering and design staff can cut down the time it takes to actually do their work. These detections have a really full and useful system of references powering their data model that I'll get into later, which is super exciting. But for now, understand that each component relates to an image, and the asset that's captured in that image relates in two ways. It relates in terms of a database primary foreign key relationship, but also every time you upload an image to Core, we analyze the field of vision for that image. So we know where on Earth this transformer is. The next flavor are classifiers. So your project will have multiple classifiers, and based on the component, these classifiers take your individual cropped bits of images. So we see we have three transformers from the last image, and then the simplest possible classifier just sorts them. These are healthy, these are not healthy. And we have default models that we'll talk about that ship with Core, and we'll talk about how exactly they work. Every transformer that's detected in an image gets sorted, right? They all get put in different bins. Here we have, of course, the classic defective looking transformer. It's very simple. This is an absolute best case scenario type of binary model. It would never be like this, but the framework is limitless in how expansive it can be. We don't really imagine people sorting components into a binary group like this, right? Instead, what we see is a future where users in Core take part in enriching their data via inspections or labeling activities, where each component receives multiple results. So insulators are first detected in each image, and then each detected insulator is inferred upon to receive its material. And then glass insulators are inferred upon by a classifier that says this one is cracked, or ceramic insulators are shown to be flashed over, or, even training a classifier, this is possible to recognize different condition codes. So if your inspectors have a large list of distribution or engineering standards, as you work in Core for free as a as a just facet of inspecting, you're receiving a training data set that actually is usable to create your exact model to do exactly what you want. So the insights we provide start with a set of base models. We have, like I say, state-of-the-art models that detect without any input or refinement, 26 distribution, 16 transmission components, and one specific type of bird's nest. So here you can see all of these components from arresters, cutouts, guide grips, clamps, electrolyers that are attached to poles. So just have your drone teams take one picture of a pole, you know where all of your electrolyers are. Splices even, we've been asked for that for a long time. Can we detect splices from aerial imagery? On the transmission side, definitely not as thorough. 16 different components, so we're up to the actual tower itself, again, splices, marker balls. That's something that we've been asked for. In terms of classifiers, we currently have 6 different conditions. So healthy, unknown is just a binary that is there. So if we don't have a condition that your component falls into, we just throw it into healthy/unknown. Defective, that's for transformers. So we have a pretty decent transformer model that can just take a picture of take your picture of a transformer and say, give you a pretty good result, similar to what a human inspector would do if he saw that or she saw that transformer. Rusted again for transformers, flashed for insulators, and then any wood, we have a model that can detect rot in cross arms. And for cross arms that have open cavities, so that is slots where you could add additional insulators or other things to the structure, we can detect with actually a really high degree of certainty whether you have remaining open positions on those cross arms. So what does it mean at scale? Well, take a look at how an inspection program has worked in core, and then how Asset Insights enhances this in terms of workflow efficiencies, tools, and most importantly, allowing utilities to invest in the future of this transformative technology and its ability to, as we'll see, to be adapted to your specific needs and challenges. So as images roll in the platform, they're geospatially analyzed and related to your network infrastructure. I wanted to show this picture. This is worst case scenario where your poles are not in the right place and your teams have to do the wonderful job of going out there and flying around a pole in reality and then figuring out how to conflate that data with that GIS database that's maybe drifted over time or it was never accurate. So we have solutions for that as well, which is part of our DSP offering, or for utilities and large capture programs that have tools, their workers have tools to overcome this. And some customers even use these clusters of drone images for actual pole correction. So you can nudge the poles to be in the center of these clusters, and all of a sudden you want a drone imagery, you've enriched your GIS database from your remote sensing activities. So I was going to show a whole end-to-end demo through slides, but we'll actually just go live into the platform now. So, but first of all, assets and their images enter a carousel for inspectors to look through. For every pole, the inspector looks at as many images as they need to make remarks on as many findings as there are. So we'll actually switch now to a live core environment. Let me find the window. All right, we'll jump to my location here in Gainesville, Florida. And when you stand up your own project, you probably want an extract from a GIS database, your GIS department, or if you are very brave and you've hired a vendor, or you are a vendor who's been told, go to this substation and walk west and fly around every pole, right? You have tools for digitization here. So what we're going to do is just duplicate a pole. I'll place it across the street from me, maybe 2 poles. Now, this is WebCore. This is the editor module where you can take full control of actually manipulating the data that's in there. And just to be very nice, we'll take a look at an attribute table. This is just a default poll. We'll rename it to demo1. And we'll rename this one to demo2. Changes that people make in core attract as well. So you can see the user, you can leave comments and see who left a comment. So we have this really nice ecosystem, fully end to end for anything that you guys need to do. And then to upload images, well, I haven't really flown around these polls on my street, but I do have some images on my computer. So I'll actually just drag this one here, and then we'll come to this poll and I'll go and drag another one. I'll try and get a nice complicated one. Here we go. And then to demonstrate the way the platform used to work, we'll come over here and we'll see these polls are different colors, right? There are other ways of filtering them, but this is to show the user a drone team has been out, somebody's been out, they've captured images, they've uploaded images, and they now await inspection. So we're going to go and make an inspection order. I am a test order with my inspection list. These are the remarks that you can make about a poll. This is a very, very embarrassingly simple one. We're just using for a demo. You can select your inspector. You can select the due date for the inspection. And now we'll actually see a carousel of images. The way this used to work, well, we only have one image. The way this used to work is that users come to core and, they scour the image. They're taking a look. Is that cutout broken? Is it open? The line has slipped off the insulator or something like that. The bolt's backing out. And their old workflow, maybe this insulator's got a problem. Their old workflow is I'm going to click this. I find the issue. I circle it. I point here. I say it's really this one. I say it's an insulator and its condition is flashed or rusted. The first tool we're adding to Asset Insights is actually an AI detection, just a time saver. So when you're making a remark, you've noticed that this insulator is broken, you're just going to select it. Have to refresh because the inference has just dropped. Yeah, I'm just going to select it. And now we just saved the small amount of time of drawing a bounding box. But when you're looking at 60 polls a day and you're marking up 10 issues per poll, you're saving 3 or 4 clicks per issue, and you're getting your work done faster. Now we'll do that again. We'll actually use this transformer. Oh, no, we'll use something else. We'll use the insulator again. We'll use this one. We'll say it's flashed, sure. Save our issue. And now the data model behind the scenes understands that a human inspector has taken our ML label. And this was, you guys saw that it took a minute, maybe not even that, took that ML detection and created a condition that's related to it, which when you find 1,000 flashed insulators and you relate them to these detections, creates a pristine data set for training your specific flashed insulator model. So maybe you have different kinds of structures, maybe you have different kinds of poles, you have a unique sensor you're using to capture the images or a different shot sheet. The quality of these component detectors is high enough that we can happily rely on their accuracy to create training data sets out of them. And then over here, if we actually come and have a look at what we've seen, what we have, our first poll where we found one issue, that is actually paired with the second poll in the order where our models actually detected faults. So at this point, if you're an inspector and you show up to your work order, when you start working, do you prioritize working on the poll that has no detected faults or the one that has, 15? I'll go for this one. And this actually is a nice segue into our review suite. So once you actually have detections that are unhealthy, you have access to this review workflow where every component will actually go to something smaller because it's a little more powerful. There we go. Where users don't even have to now scroll through the image. Users can simply use this conveyor belt. And if you think this is flashed, and I'm not saying what you want to do is spend lineman or line worker time on this. If you think this is flashed, you confirm it. And that creates that issue. If you don't think, if you discard it, well, guess what? We just had a false positive. Your version of this model that will deploy after a certain epoch or a certain amount of data rolls in, your model is now being corrected on your network. So for utilities, maybe you don't have labeling teams. Maybe you do have a team of digitizers and labelers, maybe offsite. We see this a lot. Your team can utilize this along with the inspection data. They can remark on these findings, create new issues, or something that is particularly problematic, right? You can't have the same thing flagged and in SAP or in your system of record twice. So if you confirm a detection, so actually I've already created a detection for that. And all this does is it inertly tells us that, yes, that is a correct issue that we've detected. I will say you must take part in a refinement process to get high quality results from the classifiers. Cavities is actually spot on. It will detect every cross arm that have open positions available. That may or may not be valuable to your organization. The project that we undertook in order to train them suggested that for some utilities it is a necessity. Okay. And of course, so end to end, I'm just skipping through all of the things where we actually covered it live. Oh, and actually we didn't take a look at that poll and all of its inferences. So yeah, this was just, I dragged and dropped a single image into core and we got 3 transformers, we got 2 insulators. It actually did miss a cutout, but again, we have tools for being able to draw your own and then create a data set. I don't know if that would be a good picture for a cutout anyway. Bunch of different connectors. So we're really down to super fine-grained small elements on these poles. So from image capture, upload, analysis, inference, and inspection, you can see that users are actually taking part in an end-to-end pipeline that handles these images, right? They are JPEGs, PNGs, hopefully JPEGs though, because that's what most sensors are creating. They become highly optimized. One thing we didn't talk about is that as you cycle through images in core, they will load faster than you can get them anywhere else. We've got a bunch of tricks and a ton of time invested into how fast we can load imagery. You end up with all of these components that are detected. And as your workers take part in a regular inspection project, they end up with issues and inspection results. The way we see it is that we're adding to this pipeline. So all of those inspection results still go to engineering. They still reduce the risk. But for free or nearly free as a side effect, you end up with a really exciting and useful training data set that can be used to train the next generation of models that are really honed into your network. All right, from there we have with all of the data that is in core, although I don't have one that I can show you right now, we have a integration with a dashboard platform. So the data relating to detections can be shown on an analytic dashboard. If you want to monitor the health and the accuracy, you can say, okay, I've had 25 transformer classifications, and it turns out that humans have said that only 20 of them are correct. So you take all of the ones that aren't correct. We have an ML ops team that can speak to you about how to refine these models further. In generation 2 or 3, we're looking at a version of core that can't help itself but train models. Right now, we supervise it, and we work with our partners to find and target the next model that you'd like to build in the platform. So we have reports out of core, right? Your inspection results are coming as PDFs. They're coming as different kinds of exports, right? CSVs, JSONs, KMLs, if you want, shape files, things like that. The actual images themselves, so we can export the metadata from the models. You can get the geometry within an image that the model exists, that the component exists. You can also get that stuff baked into the images. And soon, TM is access to our API for advanced level users. One more slide and then we're on to Q&A. So now what you get are state-of-the-art component detectors, faster inspection results, training data without spending additional resources, a basic set of classifiers for conditions, tools to review and retrain those classifiers, which is super important. And the next thing is refined and customized models built for your project and your network. I'll open it to questions.
Okay, thanks, James. So we did get a few questions that came in. I'm going to kind of lump a few of them together because it's kind of the same topic. But a question is, what types of images, and also, are there any resolution requirements best suited for inspections? No, you're on mute,
Yep,
James.
I had to take a sip. Yeah, so I like the question. I think what I would like to do is test. For me, for sensors, I don't think we ever got any better than the DJI X5S, right? As an inspection camera, it's a very flat image. It's about 5K or 6K resolution, and there's not a lot of post-processing on those images. So I love those. A lot of people, the DJI blacklist, a lot of people don't like exactly using those sensors anymore. So that might be out of the question. Really, if it's over a 2K image, what I'm going to do live on the call, because I think this will be fun, is I'm going to take an image and I'm going to resize it to 512 by 512 pixels, and we'll just see what it does. What it does is crash the Windows photo editor, which is excellent. Let me try this again. Yeah, any other questions? So I don't think there's any limit. I think what I suggest we do is if you're collecting images, I mean, so it's drag and drop into the platform, and then let's see if it works. If not, let's get it to work. We retrain the images. We retrain the model. Sorry, we deploy a custom version in your project's pipeline.
Okay, perfect. Yeah, we got a few more questions here. Does Core integrate with any other existing software solution within a utility company?
Yeah, so we actually have a really flexible delivery endpoint. So, an endpoint is like, think about it like a URL, right? The last thing in your URL is assets or deliveries or images. So you can type in your core URL and get that. But when you work with the API, the transfers and deliveries endpoints allow you to configure what you would call a payload. So some data, but when something happens in the platform, it transfers through HTTP protocol or HTTP to a different platform. So we've had success with Apogee, and which is I think it's a Google hosted API service where you can make your own API with Google. But anything like that will work. Anything you can access via HTTP.
Okay. Next question we have is, what are the data storage requirements for the solution?
Ooh, in is there a follow-up to that? Or Lisa, do you have an answer to that one?
Yeah, we'll see if we can get more explanation as it comes through. We'll go to the next one then. Does the AI improve over time with more use, more projects, more images? Can you explain a little bit about how long-term use works?
Uh, yes, yeah. So the way that it works, we have this thing behind the scenes called the inference pipeline, where your project is configured with all of the models that run. And then right now, which does break my heart because the vision is slightly different than this. Right now, what we do is we coordinate with our customers, and they say, "Oh, we really wish we had a classifier that could tell us when insulators were glass, right, or when cutouts are some kind of like fiber material." So what we do is we monitor. We have a trigger on our side. We have like a system of uh, triggering jobs that happen where we monitor for people's labeling activities, and they say we've labeled 1,000 glass insulators and 1,000 ceramic insulators, and that kicks off the training job, scoops up all of those parts of the images with the new glass insulators, retrains the model, refines it further, and then updates your pipeline with the newest version of the model after we've tested it.
Okay.
But yeah,
Another question that just came in, still waiting. If anyone wants to follow up with that question that was asked, we can get a little bit more clarification on that. But what imagery is being used to train these models?
oh, that's a great question. So we had access to that same EPRI data set, but Sharper Shape has about 6 petabytes, maybe 7 now. I think 7 petabytes of aerial imagery that we've captured with our heloscope. So that is a phase one 100 megapixel sensor at 350 feet, depending on the year, sometimes higher than that. And we have our first model that we trained is a pole cropping algorithm. So it just crops the poles out, and then you get something that's actually worse quality than a drone, but that's labeling that is what's given us these really strong default models. And we can add more over time. Just generation one is these 26 different components. Going back to the size question, this image is 20% of the size of the original, and you're talking about. I mean, it worked really well. I got every one of these connectors. You can see this is a blurry image now. A human couldn't inspect this image for defects. And then we went one further and we did 5% of the original image. Oh, and it did pretty well, but yeah. So if your image looks terrible, the results will be terrible. But if your image looks like a human can look at it, it's going to be really good.
All right. Well, that looks like all the questions that we have for today. Just give everyone a minute in case anyone has any follow-up questions they want to post.
And I did have a follow-up to the bird's nest. So we actually might have detected some. We were asked to train a model that detects a very specific bird's nest, and the thing goes haywire every time, and it detects bird's nests in almost every pole. So I've collected the most awful bird's nest detections that I've seen, and then some actual good results. The same model with actually data that fits its purpose works really well. So you have to think of these models as it's a machine that will make a decision for you, but it only knows the data that's gone into it. So if it's only seen this specific type of bird's nest, then every time you have a bolt that it decides looks like a bird's nest, you're going to get bird's nest detections. So, yeah. All
Awesome.
right.
All right. Well, that concludes our webinar today. Thank you, everyone, for joining us, and look forward to future emails to learn more from Sharper Shape. Thanks, everyone.
Bye bye. Thank you.